Hey everyone, this video is on solving word problems by substitution. And there is a list of things that you should do to help you out when you're solving word problems. We talked about this in the last video. Step one says to underline or highlight any key information. So I'm going to read through question number one. It says 3 footballs and 1 soccer ball cost $155. So that is some key information. It also tells us that 2 footballs and 3 soccer balls cost $220. And then it says determine the cost of 1 football and the cost of 1 soccer ball. So we've underlined and highlighted all of our given information. Then we want to determine what we want to find out. Well, what we want to find out is the cost of 1 football and the cost of 1 soccer ball. Next, we would draw a picture if we need to. It wouldn't be helpful in this question. And then we're going to need to write our let statements. And just a reminder, you always have to ask yourself, well, how many things do I not know? Okay, so you want to ask yourself, well, how many things do I not know? And this is different than how many things am I asked to figure out. You still have to ask yourself, how many things do we not know? And in this problem, we don't know the cost of a football and the cost of a soccer ball, which also happens to be what we're looking for here, which is not always necessarily going to happen. So let's go ahead and write our let statements. There are 2 things we don't know, 2 let statements. So we're going to say, let the cost of a football, and we also want to write what the unit is, so in dollars, equal, let's use F for football, and then the cost of a soccer ball equal, in dollars too. And then here, I'm going to call it B instead of S because S's look like 5s to me and I get them confused. It's totally up to you. Whatever you want to call them is totally fine. So then the next step is to write your equations. But just a reminder that the number of variables tells us the number of equations. So because we have 2 variables here, we're going to need 2 equations. So our first equation is going to be based on what's written here in highlighted here in purple. And it says 3 footballs plus 1 soccer ball will equal 155. And then our second equation is based on what's highlighted in green here. And it says 2 footballs plus 3 soccer balls will equal 220. Now that I've written my equations and the number of variables truly do match the number of equations, 2 variables, 2 equations, I can solve my system of equations. So now we're on step number 6. So this is a quote-unquote new step, but nothing really new. Remember, to solve a system of equations, you need to isolate a variable, and the easiest variable to isolate is b in this first equation. To isolate this b, I would subtract 3f. So that means I would get b equals 155 minus 3f, which I'm going to call equation 3. Now I'm going to sub 3 into equation number 2. So every time I see a b, I'm going to replace it with 155 minus 3f. Let's see what this looks like. And remember, the goal here is to go from having 2 variables, f and b, to only having 1, which are f. Now we can solve this equation. So let's go ahead and solve it. So I'm going to copy down the 2f, distribute the 3 to 155. 3 times 155 is 465 minus 9f equals 220. Collect like terms, you get negative 7f plus 465 equals 220. Subtract the 465 from both sides, you end up getting negative 245. Divide both sides by negative 7. Take a moment to figure out what you get. You should get f equals 35. So this tells me that I have the cost of a football is $35. Now I need to find the cost of a soccer ball, and I can take this 35 and really sub it into any equation I want, 1, 2, or 3. I'm going to sub this into equation 3 because in equation 3, the b is already isolated. It's just easier. So here I get 155 minus 105. When I subtract this here, I get 50. So we know that a soccer ball costs $50. Let's verify that we did this right. So we know that we can buy 3 footballs at $35 a piece, plus 1 soccer ball at $50 a piece, and pay $155. That's what it tells us in the first statement. In the second statement, it says we could buy 2 footballs for $35 a piece, plus 3 soccer balls for $50 a piece, and that would cost $220, which is exactly what it says here. So we know we did everything right. Now we just have to write our let state or our therefore statement. So I'm just going to squeeze it in the corner right here, and I'm going to say therefore the cost of a football is $35, and the cost of a soccer ball is $50. And that's it for this question. All right, let's go through and do the same thing with this question here. So it says Josh earns an hourly wage plus tips. 1 week, he worked 12 hours and made a total of $268. The next week, he worked 8 hours and earned the same amount of tips and made a total of $212. What is Josh's hourly wage? So we want to find out Josh's hourly wage. So now, drawing a picture would be helpful. So let's go to our let statements. And in this problem, there are 2 things we don't know. We don't know his hourly wage. Even though it's only asking us to tell one thing, we still don't know his hourly wage. And we also don't know the amount of tips. So because there are 2 things we don't know, even though it's still asking just for one thing in this problem, we still have to write 2 let statements. So we're going to say let Josh's hourly wage in dollars equal, I'll say W for wage, and let Josh's tips in dollars equal T. So now we're ready to write our equations. Because there are 2 variables, we have to write 2 equations. In our first equation, it says he worked 12 hours and made a total of $268. That includes the tips. So in our first equation, we're going to say he works 12 hours at a rate of W dollars per hour, plus T dollars in tips, and he made $268. Pause the video and try to see if you can write the equation for the second equation. Okay, in the second equation, it said he worked 8 hours, so 8W, same amount of tips, and he earned $212. Okay, so now we need to isolate a variable. In this problem right here, it's just as easy to isolate the t in either equation. So I'm going to isolate the t in this equation here only because in the last question, I isolated the variable in the first one. So I just want to show you that it really doesn't matter which one you isolated in. So to get that t alone, I have to subtract 8w. And this is now equation number 3. And I'm going to sub 3 into equation 1. So let's go ahead and see what that looks like. So every time I see a t, I'm going to replace it with 212 minus 8w. So this is just plain old t right here. So I can just fill in 212 minus 8w. Double check to make sure that you only have one variable at this step. And then let's go ahead and collect our like terms. This gives us 4w plus 212 I'm going to subtract the 212 from both sides, and I end up getting 56. Divide both sides by 4, and I get W equals 14. So this tells me here that the hourly wage is going to be $14 per hour. Now I just need to find the tips, right? How much the tips were. So I can take this 14 and sum it into equation number 3. So T equals 212 minus 8 times W, which is 14. So here I would get 212 minus 112, and this would give me T equals 100. So here I can say here that the tips are $100 and that the hourly wage is $14. And then we could go ahead and just write our therefore statement. So therefore, the hourly wage is $14, and that's it, because it didn't ask us to say how much the tips were. But we are asked in step number 7 to check your solution and ask yourself if this answer makes sense, just like we did in this question right here. We looked to see if our answer made sense. So if Josh is working 12 hours and makes $14 per hour, let's see how much money that makes him. Makes him $168 plus $100 in tips. It brings him to $268, which is exactly what it says he made here. And then if he worked 8 hours at $14 per hour, he made $112 plus $100 in tips. That's $212, which is exactly what we have here. So we know that those values make sense. All right, in our next question, it says a coin box in a vending machine contains quarters that are 3 more than twice as many as dimes. And it tells us that the total value of the coins is $28.35. How many of each coin is there? So we want to find out how many of each coin there is. So in this problem, again, there are 2 things we don't know. We don't know the number of quarters. We don't know the number of dimes. So here we're going to say, let the number of quarters be one let statement. Again, be very specific. Don't just say quarters. Say the number of quarters. And then let the number of dimes equal. And we'll call the quarters Q and the dimes D. Okay? And we need to write, because we have 2 variables, we need to write 2 equations. So here it says the quarters are 3 more than twice as many as dimes. So let's translate that. This is saying the number of quarters is equal to 3 more than twice as many as the dimes. So how do I write twice as many as the dimes? We would write 2D. But then it's 3 more than that, so we write plus 3. So this equation is talking about numbers. Okay? But then it says the total value of the coins is $28.35. So here we're talking about the value of the coins. If we're talking about value for this one right here, we have to think about how much a quarter is worth and how much a dime is worth. Very often people will say Q plus D equals $28.35, but that's actually completely incorrect, because then you're just saying, like, if I have 3 quarters and 8 dimes, then I have $11 or 11 cents. That doesn't make sense. You don't add up the number of coins you have to say how much you have. You multiply the coins, the number of each coin that you have, by what it's worth. So if I have 3 quarters, that means I have 75 cents, because I'm multiplying 3 by 25 cents. So here, another place where you want to be really careful is this. So if a quarter is worth 25 cents, I can write 25Q. If a dime is worth 10 cents, I can write plus 10D. And then I would say equals 28.35. Here, this is incorrect because there's a decimal place here, which means that we've got $28.35. But without having decimal places here, we are saying that it's $25 per quarter and $10 per dime, which doesn't make sense. So we can either say 0.25Q plus 0.10D, Or we could, if you don't want those decimals, that's totally fine. We could still say 25Q plus 10D, but now we have to say it's 2,835 cents altogether, right? Like if you see here, you're just multiplying this whole entire equation by 100 pretty much. Okay, you're moving the decimal places over twice. Okay, great. So now I'm going to sub equation 1 into equation 2. I don't have to do any isolating at all because the Q is already isolated here. So every time I see a Q, I'm going to replace it with 2D plus 3. Copy the rest of this down. And then I've gone from having 2 variables to 1 variable. Now I can easily solve this. So distribute that 25 through. Collect your like terms. Subtract that 75 over. You should get 2,760. By the way, this would work if you plug this into the equation that has decimals as well. Divide both sides by 60, and you would end up getting 46. So we know that there's 46 dimes. So now let's sub that back into this right here. So here we're going to say Q equals 2 times 46 plus 3. And then 2 times 46 right here is 92. 92 plus 3 is 95. So we have 95 quarters. And we have 46 dimes. Let's double check to make sure that this works. So for starters, is 95 really 3 more than twice as much as 46? It is, because twice as much as 46 is 92. Add 3 to that, you get 95. But let's make sure that it really adds up to $28.35. So if I have 95 quarters, each quarter is worth 25 cents. And then if I have 46 dimes and each dime is worth 10 cents, I get 28.35, so I know that this works. When we say make sure your answer makes sense, not only should you check this, but also like you shouldn't get, for example, in this question, you shouldn't get decimal values for dimes or quarters. Like you're not going to have pieces of a dime or pieces of a quarter. You shouldn't have negative values. Like these are things that you want to always ask yourself whenever you're working through this. So I'm going to write my therefore statement. The vending machine has 95 quarters and 46 dimes. And I think that's enough for this video. We'll take up number 4 together as a class. Once you've gotten a little bit more understanding of this, we'll do a quick take up of it before we work on the practice questions. All right, that's it for this video. Let us know if you have any questions. Otherwise, we will see you in class.